Alright, welcome to Success Enlightenment once again. It's Ishala Adedeji Michael, and we're doing a continuation of our econometrics class. Alright, in the last video, we've already established our formula for estimating the parameter of a simple linear regression using the ordinary least square method. The approach we focused on then was the absolute approach. Now we want to do some certain illustrations based on the formula we've derived there. All right. We're given this. We're given this value. We're given the value of our n, that is the number of observable data. We're given summation s, this capital x to be 44. We are given what summation y to be 69, capital y, and we are given summation capital x and y to be 684. We are given the word summation capital S squared to be 450. So with this given data, right, we are asked to estimate the parameter of a simple linear regression and interpret the result. All right, to solve this is very simple. All right, we already know the formula we are applying. We are applying the absolute formula. So, but the first thing we have to do is we have to state a simple linear regression model. Right? A simple linear regression model looks thus: y being our dependent variable equals to intercept, which is alpha, plus beta x. All right, which is beta is the slope and s is our independent variable. Simple linear, it's linear and there's only one independent variable. All right, this is a is a deterministic model. This is a deterministic model. That is, it's a mathematical model. Right, this step is called model specification. All right, in the econometrics research stage, this step is called model specification. Now we have to turn this deterministic model to an indeterministic model. That is, we have to turn it to an econometrics model by adding a stochastic term, which is an error term. That is, this model now become y equals to alpha plus beta x plus u, which is our error term. All right, this is the econometrics model. So now from here we are asked to estimate these parameters, that is our intercept and our slope. That is, we have to calculate the beta cap and alpha cap. These are the two things we have to calculate. Don't forget, we've already established the formula for this, and we've already have the data. So from here you just go straight to find beta cap and alpha cap using the absolute approach. Recall that beta cap equals to n summation xy minus summation x summation y all over n summation s squared minus summation s all squared. Y alpha cap equals to summation y summation s squared minus summation x y all over n summation s squared minus summation s all squared. All right, these are the formula we've already established. This is the formula we put in our first video earlier. When we minimize the sum of the square error, this was the formula. All right, we got. So we have to apply this formula in this scenario. Don't forget, they've already given us our n. They give us summation xy to be this. They give us summation x. They give us summation y. They give us summation y. They give us summation s squared. We have summation s, summation sy. We have summation s squared. We have summation s all squared. So all we simply do here is we just substitute this value and we find our value of beta cap and we find our value of what? Alpha cap, which are the parameter of this what? Simple linear regression. So that's what we are doing simply here. Okay, all right. Let's go ahead. Let's do the substitution and let's see what we get. First, we're calculating our beta cap, which is the slope. All right. So now, what is our n here? Our n is given to be 5. What is our summation sy? Summation sy is given to be 684. And what is our summation x? Summation x is given to be 44. And summation y is given to be what? 69. All divided by, what is our n? Our n is 5. What summation s squared? Summation s squared is given to be 450. What is summation x again? Summation x is given to be what? 44 square. So from here, what we do simply from here is what? We press our calculator. We press our calculator to know what is what? What is 5 times 684? What is 44 times 69? What is 5 times 450? And what is 44 square? Alright? That's what we do simply. So that is 5 times 684. What will be 5 times 664? 5 times 664 will be 3,420. That will be 3,420. Don't forget your minus sign. Now what will be 44 times 69? So 44 times 69 will be what? 3,036. 3,036. That's 3,036. What is 5 times 450? So 5 times 450 will gradually give us 2,250. That will be 2,250. What will be 44 square? 44 square give us 1,936. 1,936. Alright, you're not dealing with money, so there's no point putting the word, the comma there, right? So 1,096. So you subtract this from this, you subtract it from this. What do you have? 3,420 minus 30 minus 3,036 give us what? 384. This gives 384. 2,250 minus 1,936 give us 314. This is 314. So the next thing we do is what? We divide 384 by 314. So beta cap. So when you divide 384 by 314, what do you get? If you press the calculator, that will give us 1.2229. Alright? So now we can approximate our beta cap to be what? 1.22 to the nearest 2 decimal place, or simple 1.2. Okay? To 1 decimal places. Okay? So this is our what? Beta cap. You already find our beta cap. It's simple and straightforward like that. All you are doing is what? They're already giving you the value and you already know the what? Your formula. So just substitute what each of these is as it is given. And then you press your calculator, you get EA. Alright? But don't forget, we are using absolute approach. And absolute approach, we are dealing with what? The capital letter X and Y. Don't make the mistake. And they might give you in this, you can see a small letter X. They might ask you to use both absolute approach and deviation approach. Don't mistake of using the figure for what? For a capital letter X for small letter S, or small letter S for capital letter S. They are distinct. Alright? And we already know the difference between the two. So now that we find our what? Beta cap. So let's go ahead and find what is our alpha cap. Let's go. So now we want to find our alpha cap. Here is the formula. And in the question, we're already given the value. Alright, we're already given the value in the question. So what we do here, we substitute the value, and thus we have this is the summation y. Our summation y is given to be 69. This will be what? 69. What is summation s squared? Given to be 450. Okay. Don't forget your minus sign. Alright. So now, what is summation x? Summation x is given to be what? 44. Now, what is summation xy? Summation sy is given to be 684. Alright, the denominator is still the same, which is what? N. What is n? Our n is 5. summation S square is what? 450, and summation S minus summation S raised to power 2, which is 44 square. So from here we press our calculator. What will be 69 times 450? So what's 69 times 450? So 69 times 450 is equivalent to 31,050. That be 31,050. Now, what will be 44 times 684? That will be 30,096. Alright? And 5 times 450 will give us 2,250. And 44 square is 1,936. So this, if you subtract this from this, what do you get? That will give us 954. This 954. Now we subtract this from this, what you have is what? Is 314. So from here, your alpha cap is simple. You find the division of 954 divided by 314. So when you press your calculator, what you get is what? It will be 3. This will be 3.038, which you can approximate to what? 3.04 to 2 decimal places. Alright, and yeah, let's just use 2 decimal places. You can further approximate this to what? To 3. So let's just use 2 decimal places. And if you're using 2 decimal places, alright, if you're using 2 decimal places to state your alpha cap, you also have to use 2 decimal places to state your what? Beta cap. That is, don't forget our beta cap, we've already find it, so it will now be what? 1.22. So why our alpha cap will be what? 3.04. This is the what? These are the parameters of the simple linear regression. Right? These are the parameters of the simple linear regression. Now, from here you are not done. So the next thing you do is what? Is you go back to your what? To your model. Right? The model you specify, you substitute this relative value for your what? For your alpha and beta respectively in the model, then you make an interpretation of the what? Of the model. But at the moment here, you've already find the what? The parameter, right? So let's continue, let's substitute it, and let's interpret our model, and let's see what we get. Alright, don't forget once again, our model that we're talking about here, our model is y equals what? Alpha plus what? Beta S plus U. That's our econometrics model. So now our y cap, which is what we estimate, our y cap equals what? Alpha cap plus what? Beta cap x. Alright, this is what we are dealing with. So in this model now, so to what we get for our alpha and what we get for our what? Beta. So we get for our y then equals what is our alpha cap? Alpha cap is 3.04 plus what is our beta cap? Our beta cap is 1.22 capital letter x. So this is the equation. This is the equation. This can be drawn graphically. Thus, this can be drawn graphically. Thus, you have your zero here. You have your zero here. You have your x here, which is you have your independent variable, and you have your what? Dependent variable there. Alright, don't forget I said this is the what? The intercept. So this is the what? The intercept. So then the intercept will be here. This is what? 3.04, and this will be the slope, which is 1.22. Now when you look at this curve, we want to interpret it now. When you look at this graph, for the fact that we have a plus here, so the graph is positively weighted. So the interpretation for this is that what? Is that the independent variable, incoming interpretation, is that the independent variable x is positively related to the dependent variable y, such that a 1 unit increase in variable S brings about a 1.22 unit increase in variable Y. And with this, we come to the end of the what? The equation, right? So the equation is very, very simple, all right? This graph shows it up, all right? And this also shows it up, all right? The first thing you are stating has to do with what? The sign here, right? If the sign here is negative, so the relationship between the two variable, independent and dependent variable y and s will be what? It be negative. That is, this graph will be what? It will be negatively slope. That is from up to down. So that's what it will be. But in this scenario, the sign here is what? Is positive. So which means the relationship between y and s is what? Is positive. They are positively related. And by the magnitude of its alpha and beta, it shows that a 1 unit increase, a 1 unit increase in what? In this independent variable x will lead to a 1.22 increase in the what? In the independent variable y. So that's what this means, right? That's the interpretation, and with this, we have solved this question completely. But there is alternatively, but they can give you the question in this form where you have it like this, and also alternatively, they can give you a question where they will only give you the observable data, either time series data, palette data, or whatever. They give you a data, and you have to find this summation x, summation y, summation sy, and summation s square on your own. You can be given that, and after you find this, then you can now solve it like this and interpret it. So let's take example just like that, so that we have a glimpse of what I'm talking about. Let's go right into it. All right. So we're having this. If you look at this very well, they've not find summation x, summation y, summation sy, summation s square for us. All they simply give us is the what? Is the data of what? X and y. And with this data, we have to what? We have to do two things, which is to regress y on s and then to interpret the result. So the first thing we are going to do is to, at first, regress y on s. So when you regress y on s, this is what we are talking about. Y will be the what? The dependent variable. Intercept plus what? Beta dependent variable s plus what? U, the error time. This is an econometrics model, and so y will now becomes to y cap plus what? Beta y cap plus beta cap x, right? So now we want to find the value of this and this. Now we have to recall we are using what? The absolute approach. And the absolute approach, our beta cap is equals to what? N summation x y minus summation x summation y all over n summation s square minus summation s all square. While our alpha cap equals to summation y summation s square minus summation x y all over n summation s square minus summation s all square. Right. So from here now, the next thing we are going to do is what? We are going to develop a table where we can find our summation sy, summation s square, summation x, summation y, summation sy. That's what we need. So therefore, we have a table. Let's there be y. Let's here be y. Let's here be what? X. Data that is given. So data given, we have our y. When our y is 6, our x is 8. When our y is 11, our x is 6. When our y is 13, our x is 5. When our y is 16, our x is 10. When our y is 23, our x is what? 15. Alright. So we have the data that is given, which is data of x and the data of y. So the nearest one we should find This is what we can find what's our what yx or xy. Either way you put it, multiplication is what is commutative. And what is your sy? Your sy is what is s times y, s times y times s times y times s. They mean the same thing. Multiplication is what is commutative. Now what is 6 times 8? What will that give us? 6 times 8 will give us what? 48. This will give us what? 48. 11 times 6 will give us what? 66. Will give us 66. 13 times 5. What will 13 times 5? What will that give us? 10 times 5 will give us 65. 16 times 10 will give us what? 160. Why 23 times 15 will give us what? Will give us 245. Will give us 245. Okay. Now we find this. We need sy. We need sy. We need x. We need y. So now we need x squared. We need s squared. Right? We need s squared. We need s squared, which is the square of the x column only. Then 8 square is what? Is 64. 6 square is 36. 5 square is 25. 10 square is 100. 15 square is 225. Okay, it's 225. So now from here we can find our what? Summation y. Summation y will be the addition of everything in the y column. So addition of everything in the y column gives us what? 69. So equals to 69. Then summation x. That's addition of everything on the s column. So when you add everything on the s column, what do you have? You have 44. You have 44. So what's summation xy? Summation xy is simply addition of everything on the what? On the sy column, which is equals to what? 684. 684. And summation s square. Summation s square is equivalent to the addition of everything on the s square column, which is equal to what? 450. Okay, so now we are given this data, and from this data now we are be able to what? We are able to find our summation y, summation sy, summation s, and summation s square by creating this what? This table. Alright, by creating this table. And what is important when forming such table like this is this: you have to at first have a what? Remember the formula, have understanding of what the formula entails rather. So what do you need? Do you need y square? We do y square because there's nothing like summation y square here, which means you don't need y square. But we need s square because we have what? S square in the what? In the formula. Alright? So once you're here, the next thing you do is what? You go and solve the way that you solved that one earlier. Right? This was what was given. But recall, there's still one more thing we've not put here, which is our n. Alright? I told you n is the number of what? Of data. Right, number of observation. So it's just count 1, 2, 3, 4, 5. So your n is equal to 5. So it's as simple as that. So from here, let's now estimate the parameter. Let's find our alpha and let's find our beta. So from here now, we want to find our beta and our alpha. So don't forget the formula. We're using the absolute definition, that is the absolute approach. So here your beta cap equals to what? N summation sy minus summation x summation y all over n summation s square minus summation s all square. Alright, that's our beta cap. So now we already find our n to be 5. So our n equals to what? 5 into what? Summation sy. Summation x y is 684. What summation x? Summation x is 44. What summation y? Summation y is what? 69. Okay. Divided by what's n? N is 5. What summation s square? That's 450. What summation s square? Summation s raised by 2. That's 44 all square. Now, if you press your calculator. Now we can simply press our calculator here and find what this value is. Alright, once when we press our calculator, what do we get? We find this to be equals to what? 3420 3420 minus what? 3036 all over 2250 minus 1936. So when you subtract this from this, what do you get? You have what? 384 all over what? 314. So when you divide this by this, you have your what? Beta cap to be equals to what? 1.22 approximately to 2 decimal places. Alright, that's what we get for your what? Beta cap. And now that we find our beta cap, we will go with the same procedure and we find our what? We are going to use the same formula to find our what? Alpha cap. That's the next line of action. Now let's find our what? Our alpha cap. So this is the formula. So we are doing the same thing. We already have our information here. So we are just substituting. So what is summation y? Summation y is what? 69. What summation s squared? That's 450 minus what summation x 44 and summation sy is 684. Now okay, to put your is equals to sign equals to what? N, which is 5 all over summation s squared, which is 450 minus summation s raised to power 2, which is 44 raised to power 2. So when you press your calculator, what do you have when you press your calculator? What's the here? When you calculator, we have what? This is what? 31050 minus what? 30090. Okay, 30090. 30096. Right? All divided by what? 2250 minus 1936. And also when you subtract this from this, what you have is what? It's 954 divided by 314. So therefore your alpha cap will be what? 3.04 to what? To 2 decimal places. So now you find your alpha cap and you find your what? Beta cap. Now that you have estimated your alpha cap and your beta cap, so what's the next thing you do? The next thing you are going to do from here is what? You are going to go back to the model you estimated, that is the model specified. So you go back to the model specified. Don't forget what you are dealing with is econometrics. So we are also, which means the model specifies an econometrics model. So what we simply our model will simply be what? Y equals to what? Alpha plus what? Beta x, beta s plus u. This is the econometrics model. Our y estimate will have what? Alpha estimate plus what? Beta estimate x. So let's substitute what's our alpha and what's our beta here. Don't forget when we calculate our beta, then what we find as our beta cap is what? Is 1.22. So let's now the next thing we are to do is what? Is to interpret our result. Alright? Don't forget you can draw this what? Graphically. This positive relationship, which means we up. So we won't bother drawing this graphically because the last illustration we draw this graphically. So we go straight and just interpret this. So what's the interpretation? The interpretation here is interpretation the independent variable s is positively related to the dependent variable y such that a 1 unit increase in independent variable x brings about a 1.22 unit increase in the independent variable y. Alright, that is the interpretation, right? The first thing we talk about in interpretation is what? Is related to the sign. If this is negative, it shows that there's negative relationship between the two variables. But since this is positive, so that this the interpreted as x and y, the the two variables are positively related, and since the coefficient, which is the slope of s, is 1.22, so we say that a 1 unit increase in this independent variable s will lead to what? A 1.22 unit increase in what? In the dependent variable y. I've said that one again. A 1 unit increase in the independent variable s will lead to what? 1.22 unit increase in the what? In the dependent variable y. It's as simple as this. This is the how you estimate the what? A parameter of econometrics model, right? That is estimated using the absolute approach method of the ordinary least square. Right? In the next video, we'll be talking about the what? Using the deviation approach. We are going to derive the formula to use if you are using the deviation. Don't forget the absolute approach. This with a capital letter S and capital letter Y. While the deviation, this with what? Small letter S and small letter Y. That's how the name deviation comes to being. Alright, we'll do that in the next video. But here we've covered what the absolute approach to what estimating econometrics model. I remember my humble self, Ishola Adedeji Michael. This is Success Enlightenment. Don't just like, subscribe and comment, right? Feel free if you have any aspect of this that you don't understand or you attempt any question and you find it difficult to solve, feel free to contact me and share those with me, because I would love for us to learn together, and I wouldn't mind solving it and share it to the world. Once again, subscribe to the channel so that when next I make quality content like this, you'll be the first to receive notification for the video. Thanks for watching.